back to Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we profile some of the most amazing developments in science and technology. And today, once again, I'll be taking your listener phone calls. And one question I get, by the way, often, one question I get in the email is the question of why were all the computer models wrong in predicting how many people will die of the coronavirus. All sorts of numbers came out. For example, in the United States, we may experience over 2 million to 3 million deaths. And on the other hand, other computer programs said, no, it's going to be down to about 100,000. Why were these computer models so off? Well, to understand that, you have to understand that human behavior cannot be modeled correctly by any known computer. Garbage in, garbage out. Let's do a science experiment mentally. Let's assume for the moment that we do nothing. That's right, absolutely nothing. And let the coronavirus rip. How many people will die? Well, to the best of our knowledge, the fatality rate for coronavirus is about 1%. Which is 10 times higher than the flu fatality rate. But let's say 1% die and everyone gets infected. How many people will die? 3 million people. So that's where that high number comes from. That high number of 2 to 3 million deaths does not come from nowhere. It assumes that we do nothing, absolutely nothing, and let it rip. Now let's assume that everyone obeys safe distancing. Everybody has a mask. Everybody stays at home. What will be the death rate be at that point? 0. After 2 weeks, the chain of transmission is broken and the virus simply disappears because it has no one else to infect. So there you have it. Anywhere from 0, where we do everything, to nothing, where we have 3 million deaths. So how do you get numbers in between? By modeling human behavior. And that's why the models are off. Because you and I know the human behavior is largely unpredictable. We can make educated guesses, but that's all they are. And the computer models, by the way, have been actually relatively accurate. Once you put in reasonable assumptions about human behavior, the computer models get better and better all the time. Okay, well, let's throw the lines open and take a few listener phone calls. Okay, well, let's take the first listener phone call.
Hello, Dr. Kaku. My name is Fani Pandrangi. I'm from San Jose, California. My question is, theoretically and hopefully practically someday, can quantum entanglement be used to stop a pandemic by essentially turning off a virus globally in one shot? Thank you.
Well, I would like to say yes, but unfortunately the answer is no. What is quantum entanglement? Quantum entanglement says that all electrons, all atoms vibrate. And when you put them together, they vibrate in unison. And then when you separate them, according to the quantum theory, an invisible umbilical cord connects these two vibrating electrons or atoms vibrating in unison. And you can separate them by thousands of miles, even by the distance from the Earth to the Moon. And if you vibrate one, then you know that the other one is also being affected because of this invisible umbilical cord that connects the two. So this means that one day we'll be able to communicate with the moon. That's right. In China, for example, they've already sent atoms onto outer space on a satellite, connected them with atoms on the Earth, and they showed that it's possible to entangle objects from the moon, from outer space, and down to the Earth. And in fact, communication may also be possible. This is called quantum teleportation. Not the teleportation you see on Star Trek, where Captain Kirk dissolves and rearranges someplace else. No, information. The information of one electron can, in fact, be sent to outer space, and we've done it. Quantum teleportation does exist. So what's the catch? There's always a catch someplace, right? And that is, we're talking about atoms, individual atoms. To teleport a human being would require technology far beyond anything we can conceive of. We have a hard time just teleporting one electron, let alone an entire human being. So the coronavirus, unfortunately, will have to be attacked the old-fashioned way, with safe distancing, separating by 6 feet, staying at home. These things work because we want to break the chain of infection so that after 2 weeks, if everybody obeys safe distancing, then the virus cannot infect the next generation. And so the virus literally disappears. And so it's old-fashioned. We've done that for centuries, and it does work. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open. This is your chance to get on national radio and ask that question that's always been puzzling you about this universe of ours. Okay, moving on. Let's take the next listener phone call.
Hello, I'm Tyler from Salt Lake City. I have a question about the speed of light and whether to the observer, if an object traveled at the speed of light, if it would then disappear because the particles would be moving away faster than the speed of light, and therefore they would not be able to see it anymore. So it would cease to exist to the observer. I like your show.
Well, you ask a very profound question. That same question was asked by a 16-year-old boy many years ago by the name of Albert Einstein. It took him 10 years from the age of 16 to the age of 26 to finally answer that question that you just raised. So in other words, if a flashlight moves away from you at the speed of light, then you'd say to yourself, it should be invisible, because light cannot reach you because the flashlight is moving away from you at the speed of light. Or for that matter, if you race along that flashlight and you are neck and neck with the light beam and you look at the light beam, it should be frozen. It should be stationary because you are riding neck and neck with the flashlight. So here are two possibilities. A flashlight that you move alongside with should be frozen if you run at the speed of light. But if the flashlight moves away from you at the speed of light, it should become invisible. Well, Einstein finally figured it out. And that is, the speed of light is the same no matter which way the light beam is pointing. Now that violates common sense. Common sense tells you that if you're racing neck and neck with the light beam, it should be stationary. Or if the light beam moves away from you at the speed of light, it should become invisible. Nope. Einstein showed that the speed of light is the same even if the light beam moves toward you or away from you. But how can that be? Because how do you measure the speed of light? We measure the speed of light with clocks and meter sticks. Therefore, said Einstein, and this was a key observation, time slows down the faster you move. And that explains all the paradoxes of how the speed of light can be the same even if the flashlight moves toward you or away from you at the speed of light. Time itself is distorted. Space is distorted. And everything you measure is distorted. Matter, energy are distorted to keep the speed of light the same no matter how fast the flashlight moves. Now it turns out that you get heavier the faster you move, and flatter the faster you move, and slower the faster you move. This means that the energy of motion turned into mass. And the exact equation for turning the energy of motion into mass is precisely E equals mc squared. So in other words, it's just one step. Once you assume that the speed of light is a constant, no matter which way the flashlight moves, then E equals mc squared. And that is the secret of the stars. That's why the sun shines. That's why the stars twinkle. That's why we have atomic bombs and hydrogen bombs. All of that Because a 16-year-old boy asked a question, can you outrace a light beam? And the answer is no, because light speeds away from you at the speed of light no matter which way the flashlight is pointing. Now, if that violates your common sense, tough. What does your common sense have to do with the universe? That's what the universe tells us, not common sense. Okay, let's move on now to the next listener phone call.
Ben McConnell, Hope, Idaho. What about a virus test app for the smartphone with an instant readout? Would that be possible? And a temperature readout from the smartwatch. So if one was running a temperature, they could just look at their watch and they say, oh, my temperature's up a little bit. Maybe I should get tested. Would these two things be possible? The virus test app for the smartphone and the temperature readout. Do those smartwatches have temperature readout? I would think that would be something that would be good to have. Please let me know if this is possible. Thank you. Bye-bye.
Well, smartphones are getting smarter all the time. For example, smartphones can already detect your pulse rate and show you if you have irregularities in your heartbeat, signaling perhaps a heart attack. Now, heart disease is the second largest killer in the United States. So think about what you could do if your smartphone can tell you if you're having a heart attack. So already you have to put an attachment. With an attachment on your cell phone, you put 2 fingers on the attachment, and the attachment will then show you your pulse rate. Now, of course, to tell whether or not you're having a heart attack would require artificial intelligence. And so far, we don't have that yet on a cell phone. And the question is, can a cell phone be adapted to take your temperature? And the answer is yes, but it requires an attachment. And so, in other words, we're getting to the point where, in principle, your cell phone can become like a tricorder that can diagnose illnesses as well. Now, we're not there yet. There's a prize being offered for people that can create devices that you see on Star Trek, including landing a payload on the moon by amateurs, and also using a device to make your cell phone into a tricorder. That is a device which can immediately scan your body to tell you if you're being infected, to tell you whether or not you have a fever, and so on and so forth. We're not there yet, but we already have attachments that can calculate your pulse, calculate your temperature, but it requires an attachment. Now, to do a virus test would require a chemical analysis. The smartphone by itself would not do that, because a smartphone can only process data, raw data, which is binary. However, chemicals are required in order to do, for example, a PCR analysis of your DNA and of the genetic profile of the virus. We're not there yet, but one day we will have that capability. Now, today, when you go to the airport, you have your luggage scanned by X-rays. We take it for granted that there's a price you pay for getting on an airplane, because you don't want the airplane to blow up because there's a bomb on board. So we X-ray our luggage. In the future, I think we'll probably have a virus check at the airport. Again, it's a chemical analysis. It cannot be done digitally, but a very rapid saliva test that would take just a few minutes and give you a readout. Now, these things already exist because chemicals can, in fact, be used right on the spot to detect viruses. So your cell phone can't do it, but a virus checker at the airport could be the price we pay for getting on the airplane. And that indeed is coming, I think. Okay, let's move on now to the next listener phone call.
Hi, my name is Deanna. I'm calling from Buffalo. Do you believe that human beings can be somehow pulled into a parallel dimension and thrust back, unbeknownst to them, with some kind of recall of things they've seen that were just off a little from the world that they were living in? Thank you very much, and thank you for all you do. Have a great day.
Well, the short answer is no. However, that doesn't prevent physicists from speculating about what it would take to go to a parallel universe or to go to another dimension. But first of all, let's take a short commercial break, and after the break, we'll talk about parallel universes, and is it possible that one day we can talk to Elvis Presley? Back to Science Fantastic with Professor Michio Kaku. If you want to get on the air and ask that question that's always been bugging you about science, well, before the break we had a question about parallel universes. Well, recently on the web there was a notice that scientists at the South Pole found evidence for a parallel universe. Well, I read the article because, of course, I published in this area, and I realized that, well, as Carl Sagan once said, remarkable claims require remarkable proof. Now, with the South Pole, they were analyzing neutrinos, ghost-like particles which can go whizzing across the galaxy. Now, for that energy range, they expected the neutrinos to go from outer space down to the South Pole, from up in outer space down to the ground. But they found a neutrino that actually went up from the ice upwards into outer space. In fact, not one but two signals of neutrinos that went from the Earth, through the Earth, into outer space. And so the press release read, aha, these neutrinos are going backwards in time. It must be a signal of a parallel universe. Wrong. It turns out there are many other explanations for a neutrino that can go through the planet Earth into outer space, like dark matter or string theory. Many possibilities. However, that hasn't prevented physicists from really speculating about what it would take to enter a parallel universe. Now, there are several kinds of parallel universes. One kind of parallel universe talks about vibrations. We vibrate. These vibrations are cataloged by physicists. That's how we build atomic bombs, and that's how we build nuclear reactors, and that's how we know so much about the atom, by looking at vibrations. Now, it turns out that our universe also vibrates, and if we could somehow enter a parallel universe that's vibrating at a nearby frequency, perhaps we can go to another universe. So, in other words, maybe there's a universe with Elvis Presley still alive. But why can't we talk to Elvis Presley? And the answer is, we no longer vibrate in unison with that universe. Let's say I have a radio in a room, and the radio is fine-tuned to one frequency. You got that? In your room, there are hundreds of frequencies of all the radio stations, but you're tuned to just one. You're no longer in tune with these other universes, and that's why you cannot talk to Elvis Presley. Yes, he may be alive in your room, but you can't communicate with him. Sorry about that. Back to Science Fantastic with Professor Michio Kaku. Once again, we're taking your listener phone calls today in this hour. Well, just before the break, we had a call about parallel universes. And believe it or not, we physicists actively do research in parallel universes. Many of the papers that I've written, for example, are written to describe a 10-dimensional universe. So this is serious business for a theoretical physicist. However, that doesn't mean you can communicate with the parallel universe. So once again, if I have a radio in a room, the radio was tuned to one frequency, not the other frequencies. You only hear one frequency. In other words, the radio no longer vibrates in unison with these other frequencies. It only vibrates in unison with one frequency. Well, the same thing with our universe. Our universe vibrates at a certain frequency. In fact, we physicists spend our entire lives analyzing these vibrations. And another universe where somebody like Elvis Presley is still alive can coexist with us. However, we no longer vibrate in unison with that universe. That's why your radio cannot pick up, for example, Radio Moscow. or Radio Havana, because of the fact that your radio is not in tune with the vibrations coming from Moscow. In the same way, we are no longer vibrating with the universe where Elvis Presley is still alive. Now, does that mean that our loved ones who died in our universe are still alive in another universe? Well, believe it or not, the answer is yes. But here's the catch, and there's always a catch somewhere. You cannot communicate with your deceased loved ones because our universe has decoupled from that other universe. Now, there's a second way to enter a parallel universe, and that is through a wormhole. A wormhole is a gateway through space and time, connecting our universe perhaps with other parallel universes. So these wormholes are seriously looked at by physicists. If you don't believe me, simply Google wormholes in the scientific literature, and you'll see hundreds of articles about them. But again, to open a gateway to a parallel universe requires energy on a scale of a black hole. So don't think that some basement amateur inventor is going to create a wormhole machine capable of going to another dimension. That's not going to happen, because the energy required to open the gateway is the energy of a black hole. Sorry about that. Okay, let's move on now to take the next listener phone call.
Hello, my name is Alvin in Charleston, West Virginia. I'd like to ask you a question, like, do you think when the coronavirus was sent over here from China that they knew that they were sending that virus, and that's the easiest way to start a war without picking up a weapon spread by a virus? And that's all I got. What's your theory on that, sir? Bye-bye.
Well, you asked a question that's on the lips of many senior intelligence analysts, and the question is the coronavirus a weaponized virus? Well, first of all, scientists have unraveled all the genes within, all the RNA genes within the virus. We know exactly its makeup, and we find that the closest relative of that virus is found in a horseshoe bat. Now, the media initially said that the horseshoe bat was found in the wet markets where exotic animals are sold for food and pleasure and what have you in Wuhan. So people thought, aha, that's where it came from, the wet market in Wuhan, from a horseshoe virus, horseshoe bat. There's a problem with that theory, and the problem is that there were no horseshoe bats in the wet market. In other words, it could not have come from the wet market because the wet market did not deal with horseshoe bats. In fact, the nearest horseshoe bat is found 900 miles away in Yunnan. So how can horseshoe bat DNA or RNA wind up in Wuhan, which is the epicenter of the virus? And that's where the theory of weaponization comes in. Well, let's take yet another short commercial break, and afterwards we're going to talk about the coronavirus. Was it weaponized? Was it an accidental release, or is it just a byproduct of evolution? To Science Fantastic with Professor Michio Kaku. Once again on Science Fantastic. Well, the question we had before the break was the coronavirus. Was it weaponized? Well, let's take a look at the evidence. The evidence is that the animal with the closest RNA is the horseshoe bat. Initially, people said that the horseshoe bat was sold in the exotic wet markets of Hunan. That's where it came from. But there's a problem with that. And the problem is there are no horseshoe bats at the Hunan wet market. So where did it come from? The closest horseshoe bat comes from Yunnan, which is 900 miles away. Now, the bats apparently have not flown that distance. However, there are horseshoe bats in Hunan, not in the wet markets, but in the virology laboratory. There are two of them. One is safety level 2. at biosafety level 4, which is the highest, there are horseshoe bats, and they're tested. The viruses there, in fact, there are quite a few viruses which can infect the horseshoe bat. They're studied there. And so then that raises two possibilities. A, it was accidentally released from that laboratory, or B, maybe it was weaponized. And for that, you have to actually look at the genetic sequence. It turns out there are two sets of genes that are required for infection from the horseshoe bat. One gene governs the behavior of what are called the spike proteins. The spikes on the coronavirus that you see on television, they're called spike proteins, and they're like grappling hooks. They allow the virus to hook on to your cells. Now, the docking site where the spike proteins latch onto your cells, the docking site is governed by another gene, the ACE2 gene, and that gene, the gene of the virus, acts like a can opener. A can opener which first locks onto your cell in your lungs, then rips open the cell wall, allowing it to inject its RNA into your cells to create copies, thousands of copies of the virus, which would then go on to infect more cells, which will eventually kill you. And so then the question is, what about those two sets of genes? The spike protein genes and the ACE2 receptor genes that allow it to infect your cell. It turns out that, yes, we've now cataloged all those variations, and they are quite different from the SARS virus, which is a close neighbor, and they're quite different from other genes that people have looked at. So in other words, it probably was not weaponized. In fact, that's the verdict of U.S. intelligence agents who have looked at the biochemistry of the coronavirus. They say that there's too many novel mutations. If you are a weaponeer, you're going to take something that already exists, like the SARS virus, and tweak it a bit. A gene here, tweak it a little bit. But there are quite a few novel mutations that would not immediately spring to mind if you are a weaponeer. So in other words, probably, most likely, it was in fact a byproduct of natural evolution. There's simply too many unorthodox, unexpected mutations that separate the horseshoe bat genes from the COVID-19 genes. However, that still leaves open the possibility that it was released from one of these two laboratories, given the fact that that's where you find the horseshoe bat virus, at these two virology institutes. Now, the Chinese have denied it. However, there are several indications that maybe they know more than what they say. For example, the team leader, the woman who was leading the research, actually had to go through her files to make sure that the coronavirus was not one of the viruses she was studying. And she's quoted as saying she was relieved. She was relieved to find that the coronavirus genes, the COVID-19 genes, were not identical to the genes that she was studying. However, that raises the possibility, again, of an accident. Maybe the precise genetic profile was not found in the dictionary of viruses that she was looking at. But the very fact that she was looking at these virus genes means that that is perhaps the closest correlation we have found so far to a virus which resembles the virus which causes COVID-19. Now, is this the smoking gun? It's close, but it's not the smoking gun. She has denied that it's one of the viruses they were looking at. But the very fact that they were looking at horseshoe bat viruses, the very fact that they were looking at the genetic profile of these viruses, leaves open the possibility that it was accidentally released. Not the smoking gun, but it means that the Chinese government has to fess up and reveal exactly what has been done or what was done in November and December of last year with these horseshoe bat viruses. Well, unfortunately, I see that we have run out of time. Once again, you've been listening to Science Fantastic with Professor Michio Kaku.